Python isn't just something that's kind of taught in the university systems and then never seen again. It's something that's very pertinent in industry in those kind of 4 areas that I was talking about. But not only that, not only is it used in industry, it's actually used in industry by a lot of the top companies. So a quick search on Indeed.com or even LinkedIn will kind of reveal to you that what employers are really looking for is Python skills. And it goes a long way. And that's kind of what we're trying to do here, just equip you with some basic knowledge so that you can almost go on your own and study some of the more intricate nuances of Python and what it has to offer. So if you've ever wondered how things like Netflix's recommendation system is built, like how they seem to just always recommend the perfect TV show or movie for you, or how self-driving cars are made, like the algorithmic underpinnings behind that, it's all, one, it's machine learning, but a lot of that machine learning is actually being implemented in Python, as opposed to something like R, which is a little bit less evident in industry. So, cool. I guess we'll now get into the code where we'll just kind of run through some basic syntax. And then once we've run through some basic syntax, we'll do some pretty basic analysis on a sales data set, just to kind of get an intro to data science and just an intro to exploratory data analysis, like looking at a data set and trying to gain like some special insights from it. So I'll move it to Julian now, who will share his screen with some of the code that you guys did. Okay.
So just give me a second to share. Here we go. So I'm guessing everyone can see my screen. So here we'll just start off in our repository. So for those of you who don't know or might not know about GitHub, GitHub is just a centralized location to keep your code, and it keeps it effectively what we like to call version controlled. So you can constantly version your software. And along with this workshop, there's actually no need to install Python yourself. There's actually a lot of great tutorials out there. So if you want to know how to do that, it's very easy to find heaps of tutorials on YouTube. But for this workshop, we'll be using Google Colab, which is a notebook that you can run Python interactively created by Google. So I'll ask Noah if he hasn't already to share this link here with everyone. And once everyone's here, what you can do is we'll go to Google Colab. Go to Google Colab with that link copied. We'll paste it in here in this GitHub tab here. And you can see that the Intro to Python 2022 notebook has appeared. So we can click on that. And already we can see our Python code has been loaded up. So what we can do is we can press connect for Google to allocate some memory and some CPU usage to us. And once that's ready, we can get started. So as said in the, yeah.
Sorry, is there any chance, just for anybody who might have missed that, if possible, is there any chance you could run through that just one more time, just in case anybody like got left behind or something like that?
Yeah, sure. Okay. Sure. So what I can do is I can go through exactly the same thing again. So we start from the GitHub page, and there's this README you can follow that should give you the exact same steps that I've been given. So we go to Google Colab, switch to the GitHub tab, and then you paste the URL in, and it should appear. So I can do that one more time quickly. So here, there's this GitHub tab. Paste it in here, and then you should be getting this Intro to Python 2022 notebook. Otherwise, if it doesn't work for you, feel free to just watch, or you can actually download the code yourself from GitHub and run it locally if you have Python installed already. I hope that that's okay with everyone. Please, if you have any troubles, ask in the chat, and I'm sure Noah will be able to help you out. But with that said, we'll get started with print and input statements. So print and input statements are one of the most fundamental operations in Python. I like to say it's the bridge between your program and the outside world. So what that means is if we just run a Python program, we'll actually never see what it's doing unless we're printing. So a classic way to start this, if you've done any sort of coding, you'll see the classic hello world. And in C, I don't know, it might be, 10 lines or something. In Python, it's 1 line. And yeah, if you see this warning here, it's totally fine. It's just Google giving us a warning. And that's it. So the way that we print in Python is simple as just saying print and putting our whatever we're going to print in brackets here. And of course, we can extend that later with putting variables on our print statement, which I'll go through a bit later. We also have input, which is a way for the user to enter information or data into our system. So we can do that here with this input function here. And how it works is this beginning sort of string here will be what it prints, and then following will be what we can input. So I can just type in hello world, and it'll repeat back to us what we've said. So one thing to be careful with print statements is quotation marks. And there's 2 types of quotation marks. And I think here I've actually pointed out that there's an error here. If I run this, it's going to say invalid syntax. If anyone knows why we're getting the syntax error, could you put it in the chat? I'll give maybe 1 minute for anyone to think. Yep. So Julian has got in the middle. So what exactly about the middle? Yep. So what should I change it to? Yeah. So Zach has got it. Exactly. Thank you. So the problem here was that we used another double quotation, and that basically ended the string, and we got a syntax error. And the way you fix that is by just using a single quotation mark. So you may also be wondering how you might be able to embed something like variables in your print statement. So we do that with string interpolation. So let's say we have some input here, and in Python, there's 2 ways of doing string interpolation, or 2 major ways at least. We can use this dot format function, which is followed after strings, or we can use something called f strings, which basically puts an f before strings, and then you can put your variable effectively inside these curly braces here. So if we run it, as you might expect, if I say something here, exactly the same output, effectively, it's going to print exactly how we expect. So there's a small tip there. And if you want to explore more, there's heaps of documentation online, so feel free to look it up. So moving on, we've got variables, data types, and arithmetic operators. So here I've got a list of all the data types possible in Python. And it's actually pretty daunting how many types of data there is, stuff that you might never use, like there's bytes, byte array, memory view, and things like frozen sets. So perhaps maybe the most commonly used types of data, we might see text data, which is strings, numeric types such as int, floats, and complex, which is for your complex and imaginary numbers. We also have sequence types, so your lists, which are also known as arrays in other languages like C, tuples, and we have this weird sort of type called range, which we'll go through later. We also have or dictionaries. So that could also be thought of as maps in other programming languages, or hash maps, if you've heard of that before. We have sets, which is exactly like what you expect in math. So they try to mimic the same sort of operations that we can do with sets in, I guess, discrete math. We have Booleans, which is true or false. And we also have these binary types, which I won't be going through too much since we rarely ever use them. But if you are interested, definitely have a read. So the way to declare variables is quite straightforward in Python. You basically have your variable name here on the left and exactly whatever you want to assign it to on the right. And as you can obviously tell, unlike C or other programming languages, Python, you don't actually have to declare the variable. So we call that dynamically typed, which means that we can actually assign or change the variable without ever declaring its type. So here we've got foo, which is an integer. We might as well change that to a Boolean variable. We can also check the types of our variables by using this type. It's not as used. It's not used very often, but it is quite handy in some circumstances. So we see here a string is obviously a string. If you've also worked in C, or I guess any other programming language, we can do typecasting. Typecasting is effectively casting a variable from one type to another. So effectively just changing its type. So here, it's very common, especially in data science or data analytics, that we might get a data set that is not formatted correctly. We might get numbers that are strings. And Python, it's quite easy to actually change that to an integer. So you can see here that it's initially a string, but we change it later on to an integer. And next, we've got some more of these sort of sequence types here. So we'll start with lists first. So unlike most other programming languages, a list can be filled with variables of multiple types. So here we've got a list of integers, and we also have a string here. So the way that we actually index into lists is quite straightforward. We just put in these square brackets here and whatever, I guess, part of the list we want to index to. So note, if you're familiar with programming languages, we can only index between, we index starting from 0 up to the size of the list. So here, if we count, it's starting from 0, goes 1, 2, 3, 4. So if I go 0 here, should print. It comes up with 1. And that's what we might expect. So what do you think would happen if I index 5? Can anyone tell me in the chat? 5? 4, sorry, says Julian. So maybe it's unexpected, but as we said before, indexing, since this size of this list, if we count from 0, 1, 2, 3, 4, okay, so maybe you were trolling a bit, that's fine. But it's still good to point that out, that if we go past 4, it's gonna give us this error here, index error. So that's like any other programming language really. So what, I guess, if we wanted 4, we'd have to put in the index 4. So we can also, there's also other ways of indexing lists that might be unfamiliar to people who might be used to C. So we can use this colon here to give a range. So if we wanted to, let's say, give a range from everything beyond this first element here. So if we wanted to start, let's say, from 2, so this would count from 2, 3, up to just this part of the list. We can also give a more stricter range, or there's also ways to give the end of a list. So I really employ you to look into the many ways you can index a list, and that's why we have this notebook, is you can actually play around in it yourself. So moving on next on the second part of lists, there's a question of how do we add onto lists. So that's also quite simple. We can call this append function to append to the end of a list. So perhaps I wanted to add true. and we see that it's appended it at the end. So of course, as you would have expected, append doesn't actually return a new list. It changes the list directly. So you might think that's handy or not, but that's just something we have to live with. And of course, I could have done anything else. I could have put a string here. So I guess that just demonstrates the how dynamic Python is. Moving on to tuples. So you might be asking what's different about a tuple. And not much from the indexing perspective. This runs. So I should have stated that in Jupyter Notebooks, which is what this sort of software is called. If you put something at the end without a print, it'll just print it at the end right here. So as you can see, I've got this my tuple, and I'm indexing for 0, and I've got 1. So can anyone answer? What do you think is going to happen if I try to append an element to a list? If I run this. Can anyone guess? If I were to run this right now, what do you think is going to happen? Of course, you can look it up, but given what you know about lists, okay, so Julian has got somewhat of a hypothesis of what might happen. And I guess since I've asked the question, you're probably suspicious. So let's see what happens. And we see that we get this weird error that says tuple object has no attribute append. So what this means is that there's actually no way to append to a tuple. And what that means is it's immutable. And for those who are maybe unfamiliar with these sort of computer sciencey terms, there's a difference between something that is mutable and immutable. So a object that is mutable means that we can actually change it or add elements to it, which is exactly what we see for lists. On the other hand, for tuples, we actually can't append. And what we'd have to do is we'd have to basically just create a bigger tuple effectively, or we can also concatenate tuples together. Finally, with dictionaries, you see that they're a bit stranger looking objects. And for people who aren't used to Python, this is completely new, or this concept of dictionaries is completely new. And in my opinion, replicates mostly what a data set looks like. So you have headings here and you have your data here. And how you access elements, since we call these hashable, means we can actually put a string in here. And if we were to print this, show the result, we're going to get degree as expected. So usually the structure of a dictionary follows a key value structure. So what that means is we have some sort of key here. So the key in this case is name and a value, which could be literally anything. So I could have name. If I do this, now it's a list. And if I go name, we're going to get this list. And I guess this replicates more of what an actual data set might look like. And of course, we might also want to know how to create new elements. So the way we do that, a simple way at least, let's say I wanted to add year to this data set. I could just add in like this, basically creating a new key and then adding my value here. See if I show this here. We have year added. It's easy as that. And of course, this is super simple for all of these structures, but I hope it's given you some sort of introduction, and I really urge you to look into it because it does get quite complex. Moving on, what is also important in Python is to understand arithmetic operators and I guess your general sort of operators. So for arithmetic here, I've just got a random assortment of all sort of Python arithmetic operators here. So there's the classic minus, there's this times here, divide, and then there's this weird looking symbol here. Can anyone guess what that means? this symbol right here, this double asterisk. Power, yeah, exactly. So in this case, we're doing this bracket here to the power of 4. And once again, there's heaps of other sort of arithmetic operations we can do. We can do modulus. So if you've done discrete math or C, you might know about modulus. So if we want to find out if something's even, so maybe the question is, do we want to know if 4 is even? So we could do 4 modulus 2. And that's 0. So effectively, what that means is we're getting a remainder, and the remainder is 0. And that's basically telling us that 4 is indeed even. Compare that to 3. We're getting 1. So what that means is that 3 doesn't divide into 2 perfectly, and we're getting a remainder. And that remainder is 1. And you'll see later how we'll use that to calculate if things are odd or even. Next, we have operators. So you might have guessed it could have been way easier if we had just done this, right? If we had gone and figured out if it was odd, we could have said, is this 0? And that answers our question false, right? 3 is not even. And effectively what this double equal sign is going to return a Boolean. And that's quite helpful in the case for if statements, which we'll see later, or answering these sort of simple questions. We also have these less than. We could also do greater than equally, or we could do less than or equal to, or greater than or equal to. And of course, we have and. So you might have seen in C, I believe, you have ampersand as and. In Python, we have literal and. So what you might notice about Python, it incorporates a lot more natural language, which might be confusing for others, for some, or easy for others. But over time, it gets a lot easier. So here, if we run this, we get rid of this. You see the output of all of these mathematical operations. Of course, I could have done or here, and that's another important operator. And we would get different results, I believe. So here I've given you a space to have a play around with operators, look them up. There's many more that I haven't listed, but once again, it's sort of an introduction. And of course, speaking of help, there's this neat help function here, or there's that will give you the documentation. So for list, we can see we've got all of this sort of documentation. So we've got our append here that we learned about before. There's also insert, there's extend, all of these you can learn about and read up on. Similarly, you could have for dictionaries, same thing. Get rid of that. And another important function is dir, which is going to give you the directory effectively, or what's available. And as we can see, we've got a bunch of stuff here. So some important ones, pop for removing items, get for getting items, I guess. And we also have a bunch of these sort of, we call them private values, or things that shouldn't be touched effectively, or things that the user shouldn't know about effectively. And this is often used in, I guess, in software packages. So moving on, the next sort of coding paradigm that we can look at is control structures. So control structures effectively control the flow of code. And they basically let the computer do the boring and repetitive stuff that actually adds complexity to your program. And the two main types of control structures we'll be looking at are if statements and for and while loops, which are quite similar. So you might have known about these. They're, I guess, common across all programming languages, but I believe Python implements them in somewhat of a unique way. So here we've declared two variables, and we're going to do some, I guess, logic checking here to see what the outcome might be. So the standard sort of procedure in Python for if statements is we have if, this elif which in C is else if, and then finally else. So how it works is we first check this if condition. If that's true, we print this. If it's false, we then check the next else if statement. And if that's true, then we print this. And then after that, if all else fails, I guess, then we go to else. And this will always print. It's basically a catch-all if everything else fails. So Sina is asking, does Python have switch statements? No, not that I'm aware of. They do have case statements, case match. So case is similar to switch. I would call it switch-esque sort of. You can look up what that is. It's quite popular in your functional programming languages, which is what sort of Python pretends to be. And I think I don't know what version it's implemented in, but it is quite new. Yeah, as Noah said, it's complicated. So moving on, if everyone's happy with that, also asking Sina, did you personally use it? I personally use if statements. I think that's just how I was taught. Yeah, I mean, really, I don't want to say that you can't use anything. Whatever you're comfortable with, you can use. And if it works, then it's totally fine by me, really.
Sorry, just if I can, just for 1 second. If you guys are familiar with case and switch and everything like that, it might be worth noting that in Python 3.10, which is quite a new version of Python, they actually have incorporated like some sort of like case, similar syntactic structure. So that Stack Overflow post that I just attached there, that is kind of, it just reveals like some of the intricate syntax that you're getting in Python 3.10, which is quite a new version. And that kind of actually does have case, but generally going with if statements is 1, easier to comprehend and read, and 2, just nicer syntactically. But you can technically use case in newer Python versions.
Yeah. One programming language that comes to mind, if you've heard of Scala, which is like a huge sort of programming language in machine learning engineering and data engineering, case statements are quite frequently used, and it's quite good habit to use them. And that's what you see in functional sort of programming languages, if you want to look that up. So moving away from that side tangent, thanks, Sina, that's great. Onto loops. So loops effectively, as they say in the name, they loop. So if you're used to C, this might look a bit strange to you. It's a bit more natural language than actual sort of rigorous programming, should I say. So here, if I break it down, we have for, which is how you start every for loop. We have I, which is our variable, which basically, as C effectively, we have I as our standard sort of iterator. And we have this weird sort of statement that says I in range 0 to 10. So what this means is typically the sort of structure of a for loop, as I said, is we have this for here, and we have this iterator, an iterable. And iterables, if we go back, are typically these sort of types. So we have lists, tuples, range. They can also be dicts. They can also be sets. And there's many more that I'm probably missing. But effectively, range is a function that is going to give you an iterable that returns, an iterable between 0 and 10. So what it's going to do is every time I is going to be assigned in between that range, and it's going to increment for you automatically. And one thing you should note about, if I can get, nope, okay. So it starts from 0. And basically, you might think that it ends at 10, but what you'll actually find is that it ends at 9. So I was trying to get the documentation up before. Perhaps I can. See what it comments about it. Yeah. So as you can see here, there's multiple ways of doing a range. Like you could also just have it as stop. You could have it, you could provide a start, a stop, and a step. So maybe you don't want to increment by 1, you want to increment by 2s. And as the documentation says here, if I do a range 4, it's going to produce 0, 1, 2, 3. And the kind of way that we write for loops is that it doesn't even have to be I could have said anything effectively, but the point is that this I here, whatever variable I choose, is going to be assigned. It's going to basically, whatever iterable, when the for loop goes to the iterable, that this variable is going to be assigned each element of the iterable. For loops can get confusing, and it takes some practice to get used to the natural language of Python, but hopefully going through some examples actually helps. So here we can see that I takes obviously goes from 0 to 1 all the way up to 9. And what we're checking is, as a for, we've got our modulus command checking if I is even. So 0 is even, 1 is odd, continuing. And we've also incorporated if statements. So this is typically what you might see in Python for loops and if statements. And yeah, it's as simple as that, but it does get complicated quite quickly. If anyone has any questions on that, I can quickly stop to answer any questions about for loops. Maybe I'll wait 10 seconds because for loops are extremely important concept in Python, but they can be quite challenging. Oh, okay, all good. So moving on to while loops, very similar to for loops, maybe slightly easier to understand, and they follow pretty much exactly the same as C syntactically, if you know C. So we have while, to start the while loop, we have our variable, and we're basically checking a condition each time. So when this while loop loops through, so I will start at 0, we first check in the while loop, is I less than 10? Yep, 0 is less than 10. Go into the while loop, it'll increment it. Now I is 1, and we check it again. Is 1 less than 10? Yes, keep going, keep going. You can see how it does automate a lot of this boring stuff. Okay, Sina is asking, my preference between while is better or use for loops. Typically, I use for loops because it's so much quicker and so much cleaner, but there are some cases where you might want to use a while loop. For example, if you're checking a condition inside your while loop, I can explain this better effectively. But if I go through this example first, I will handle your question next. Yep. Yeah. So the problem there was just a indentation error. I'm not sure why that happened or fixed it. So as you have guessed, I guess I have seen Python works off of indents. It's no braces at all. So you have to be quite careful about how you're indenting. And Google Colab, I think actually it's a Google standard that they use 2 spaces for indentation. Someone might correct me on that. Anyways, so we see that our while loop, after incrementing, it ends up being 10. And finally, once we get to 10, 10 is not less than 10. So we exit and we print I. So answering Sina's question, I might just quickly go through an example when I might use a while loop. So if I want something like I'm checking something, check it's false. I can't think of an example. Oops, I should change this to true. I can't think of an example directly when I might use this, but this might be something I might use it in. So if we're doing while check, I could have something like this, where effectively what I'm doing is I'm going to be doing something in this while loop, and then eventually I'm going to be changing check to false. And then once that happens, effectively, it's going to change check to false, and it's also going to exit this while loop. So I believe this could be useful if you're doing some sort of like an event loop. So if you want to keep looping over something until it's met some sort of end game condition and then you change your check to false, and the while loop will exit. I hope that's answered your question. That's probably the only example I can think of. Noah, can you think of anything else for that?
Yeah, I guess if you're trying to iterate like through some numbers, maybe you want to print numbers up until you get to like 100. But if you don't actually increase your counter, it's going to get stuck at the same number. It's just going to print the same one over and over again. So what kind of happens is, if you're not careful with while loops and a condition always evaluates to true, there's nothing that's going to break it outside of the loop. So you can get caught in the loop, and that's when programs will, exactly as Julian's about to demonstrate now, you'll see here that while I is less than 10, we want to print I. But what's going to happen is we're not actually increasing I, so it's just going to keep printing 0 over and over and over and over again. So if you wanted to actually stop this while loop, you'd have to say like new I is equal to old I plus 1 to actually increment I, so that's something bigger.
Yeah, this is the classic example. And if you do this, your program will keep going until, I don't know, until Google Colab is going to shut this down, I guess. So I'm going to stop this because it's going to crash eventually. There we go. Okay, so we pretty much covered a lot of the basic concepts for Python. And we're going to be moving into some sort of simple exercises that I guess have for each exercise a little sort of challenging sort of aspect to them. So hopefully everyone has their notebooks open and wants to give these examples a go, but I'll effectively walk through every single exercise. So this first exercise here, the challenge is to use a loop to display elements from a list only if the index is odd. So for an example, we've got this list here. We want to basically get this output here. So again, if we count this list using its indexes, 10 is 0, 20 is 1, so on and so forth. And we basically, since this 20 here is 1, doing a modulus on 1 is going to be give odd, basically, so we don't want to print that. So there's a few tricks in this, right? We can look at this enumerate function, and you don't have to get this output exactly, but there's also to actually get this output exactly, there's a trick with print, with one of the parameters in print that you might want to look up. Otherwise, it's totally fine if we just print a new line, which Python automatically does, unlike C, which you have to put a new line character manually. So I might give everyone maybe a minute or two for this exercise. And we'll come back and see if anyone wants to give me their solution, and we'll step through it. So I'll just give maybe a minute from now. While we're waiting, if anyone has any questions, feel free to put it in the chat or Slido. Cool, so hopefully that was enough time. If anyone wants to give me the solution, I know I gave you guys 1 minute. Maybe that was too ambitious of me, but if anyone actually has a solution and wants to put it in the chat, I'd be more than happy to look at it and we can analyze it together. It's totally fine. I can do it. So I'll walk through the solution. And the trick here is to use this function called enumerate. So I'll present the documentation. So what Python says, it returns an enumerate object. So this is kind of unhelpful. But if we look at one of the examples here, what it effectively does is it's returning an index list. So each time we're getting the index as well as the element. So how we do that in a for loop, this for, we might use I for our index, and we could use something like lm for our elements in enumerate. And if we I lm, it becomes pretty trivial after this now that you see that you have exactly what you need to check. So what we can do now, we just do a simple check to check if the index is odd. So how we do that, as I showed before, we do a modulus on 2, check if it's equal to 0, and then we print the element. And there we have it. Of course, I checked if they were even, so the question asks for odd. So I'll just change a double equal to this exclamation mark, which means negate effectively, or not in other terms. So we've gotten our expected output, but as I said before, there's a trick to doing this, to getting it exactly like this, which might be especially tedious, but we can use this parameter called end here. So what it does by default, and of course Google Colab will show us the documentation, end by default prints this new line character. So in C, we have to do that manually, but in Python, it's going to actually create a new line every single time. What we can do is change that to a space, and now we have our output exactly. That's kind of a cool tip if you want spaces or you want your output on a single line rather than a new line. So if there's no questions about that, I can move on to the next exercise. So exercise 2, the problem is given a character and a string from the user. So we want input. So we want both character and some sort of string or sentence as input. Replace all occurrences of the character in the string with this hash. So that kind of sounds confusing. So we'll give an example. So let's say we take input from the user. We take a character, it's J, and the string is Julian. And what we want to do is we want to replace this J with a hash. And this is kind of very sort of data science-y-esque sort of problem, because again, as I said before, in a data set, there might be a lot of problems with your data. So it might be very common, or it is in fact very common, that you have to change strings, you have to manipulate them in some way. Maybe it's a URL, it could be someone's email address. So this is quite good practice actually. And this one is a bit harder because I haven't taught it to you necessarily, but I've got this hint here saying, try to look up what functions are available for strings in Python. And what I'm trying to teach here is that effectively, there's no need to write a lot of functions yourself, or a lot of I guess string manipulation sort of tools yourself, because Python implements them for you, and one such thing is replace. So I urge you to look up. There's actually a lot of string functions or ways that you can manipulate strings, so such as making them lowercase, uppercase, and of course replacing, which I will show you. So as revision, we'll take a character from the user. Also take a word, could be a string, or just or sentence, sorry. So word, and easy as this, all we have to do is this dot replace here. And as you can see, the Google Colab gives us documentation saying we've got the old, basically, and new. This is kind of actually confusing in Oh, no, it actually works. Never mind. So effectively, these, what it's saying is you want your, whatever you want to replace, so our character, with new. So that's the hash. A little bit confusing on Python side by new and old. However, it should work. So if we take in the character J, word William, and it's replaced it. Now, what do you think is going to happen if I put another J here? So if I put J, and if I do like this, is it going to replace it or not? Is it going to replace one J? Is it going to replace two J's? How many J's do you think it's going to replace? Both, says Ben. Anyone else? Well, let's see. Ben was right, exactly. So it's going to replace every single instance of the character with our replacement string, which is this hash here. And that's very useful, as I said, in data analytics and data wrangling and that sort of thing. So I don't think we have time for the last exercise because I want Noah to have as much time as possible. But this is also a pretty good exercise that deals with data wrangling. And we've got this data set here. So we've got name, degree, WAM, academic standing, and effectively the exercise is to remove the given fields from the data set. And by the given fields, we want to remove WAM and academic standing because I don't like my WAM and academic standing. I want to remove it from my transcript. So as you might expect, we've got this example here, and the expected output is just my name and my degree. So maybe that's something you can try in the next minute while Noah sets up his screen. Or you can do it just by yourself in your own free time. But if there's no other questions, I'll hand it over to Noah, who's going to handle functions and some data wrangling, I believe.
Perfect. Thank you very much.
Sure.
Well done. Cool. Okay. There we go. Okay. I think I shared the wrong one. Cool. Might take me half a minute.
Yep. If anyone has any questions, let me know. There's also Slido again. If anyone wants to put a question, it's definitely going to get answered. That might that will answer at the end effectively.
Cool. Sweet. Jules, can you see my full screen?
Yep, perfect. All good.
All good. Okay. So first of all, hope you guys are enjoying the workshop. One thing just before I started, I just want you guys to know that if you guys didn't take all of that in, that's perfectly fine. There were like a lot of concepts there, and this is not a skill that can just be developed in like an hour. A lot of it is kind of the work that you put like in your own time, doing your own sort of exercises. But it's a really good foundation, and I think if you really want to nail down these concepts, the best thing that you can do is actually look at our notebook, but then also try attempt some exercises on your own and use our notebook as like a framework for answering those questions. So I guess we'll move on to my part now. We'll go into something called functions. And if you're coming from other programming languages, the concept of function stays the same. The way that they are written out in Python changes. So that's if you're familiar with functions. If you're not familiar with functions, simply put, functions are just little pieces of code that you can place in multiple parts of your program. So let's say you've got a massive 10,000 line, it's not that massive, but let's say you've got a 10,000 line program and you want to perform a task many times within that program. What you can do is just write up the function once and then use that function that you've just created at multiple stages of your program. So a function that you might write could be like build a model, and then there might be various cases in which you want to actually do that task. And And so that's kind of what functions are for. It prevents you from writing the same code over and over again. So you only have to write the code once, and then you can insert it at different points of your programs at various points. So that's essentially what functions do. Almost similar to a mathematical function that takes some sort of input and often generates an output. So a lot of the concepts have actually just been stolen from math. But if you're not a mathy person, all a function really does is just perform a task. And that task can be placed in multiple parts of your program. So that's actually say we wanted to create a function and we know we're going to use it, but we're not sure what's going to go inside it just yet. So with all Python functions, we want to define what the function is. So a simple DEF says, okay, I'm defining a function. What do I want this function to do? Well, we're not sure yet. So let's just say do nothing. And we open some parentheses. Now, what happens is once you've defined what your function is, so our function is literally to do nothing, what we can say is, okay, well, I know I want to add some code to this function later, but I'm not really sure what to add now. So let me just pass by and go to the next line of code. And so what happens is, if I didn't put this pass and I ran the code, you would actually get an error. So just to tell Python, listen, I do want to create a function. I want to create this function eventually. I'm not sure what I want to put in it just yet. So I'm just going to pass by this line of code and go to the next one. Okay. So that's a function that does absolutely nothing, exactly what we told it to. Okay. And that you'll be using that more often than you think, because you might have an idea for a function, but you might not have other code yet to kind of back it up, but you know you do want to create that function. So just that, like, so you don't forget about it, you could put the name of the function and just say pass. Let me just move on to some other code in the meantime. The next thing that we can do with functions is actually insert things inside of these parentheses, and I'll show you what that means and why we do that. But let's say we wanted to create a little program that calculates the area of a circle. So just a circle. And if you're familiar with a little bit of year 8 math, if you want to calculate the area of a circle, all you need is just like a little radius, which is like from the center of the circle to like the end of the circle. Your typical pi r squared that you learned in year 8. So why don't we define a function that actually computes the area of a circle? So we could define a function here using DEF. What we really mean is like define a function, but Python, the computer sees it as def. And what does this function do? The function says we want to calculate area. I could have written calculate area, but you know what, I might as well just do that. So calculate area. Now, what do we need to calculate area? We need the radius of the circle. So we can just say it takes in a radius. Functions are allowed to take in nothing, as you saw here, but they can take in one input, or they could take in multiple inputs. Let's say you want to calculate perimeter or something, you need like the length and the width. So you could have like two, we call these parameters. This radius thing, the thing that goes inside of these parentheses, is a parameter. So we've just got one parameter here. You can have multiple parameters in a function, as well as no parameters. So the way in which we calculate area of a circle is to take pi, which you guys might know is 3.14, and we'll times it by the radius squared. Now, how do we do that? Well, we'll take the radius. And how do we exponentiate something in Python? Well, as you saw from Julian's part on arithmetic operators, you can just double star it, and that will raise it to the power of whatever number you put after that. Now, what you might have noticed is that 3.14 isn't exactly what pi is. It goes on like 3.141, and the list goes on. So what happens if we actually wanted an exact value of pi? Now, we know that pi is infinite, so you could type in 100 values of pi, but it still wouldn't be exact. So this is the concept of a module in Python. So what we've done in Python has just kind of been using built-in functionality that Python has to offer. What people have done, what developers have done, is they've actually created their own code that can like do extra stuff that adds functionality to Python. And what we do is we import modules. So we take code that somebody else has written and we use it in our own program. So what we can do here is there's a special module called the math module, and the math module has all sorts of fancy operations that you can do, like sine and cosine, like any trigonometric things like that, factorials, if you're familiar with that. So what we'll do is we'll actually import the math library into our program. So we'll import math, and this takes all the mathematical functions that has been created in this math module, and we can use it. Now, it turns out there's something, if we want to access pi, we can actually take math.pi. So the name of the module, dot pi, because pi is built into the math module. If you type in math.pi, you'll get an exact value for pi. So if we look here, so math.pi, we've actually computed the area of a circle now. Now, what we actually want to do is we want to have this value returned back to us so that we can get this value returned back to us and then use it at some other point in our program. So what we do in this case is we just ask Python, can you please return this value? Whatever this value is, we don't know what it is yet. It ultimately depends on how long the radius is, but whatever it is, just return it back to us so that we can use it at a future point. Okay, so I've created my function. And what I can now do is way later on in my program, wherever that is, let me just put it here. Let's say I want to calculate the area of a circle. I can say, okay, I want to call this function. I actually want to calculate the area now. And let's see what happens if I make the radius 3. What will happen is it will give us a value for what the area is. And what I can do now is instead of writing this code over and over and over again, I can say, well, I want to calculate area at this point in my program. I then want to calculate it like here as well, here as well. And instead of writing the code that's actually required to calculate the area, you can just call the function and insert it in your program at multiple points. And again, you could be all fancy and ask for some user input instead of me just like plugging in different values here. But ultimately what's happening is we are creating a function that we can, instead of rewriting the code for it, we can just call it at multiple points in our program. Okay, now here's a far more complicated one that I promise I will explain. And what you'll notice straight away is that in this, going from this block of code here to this block of code, I put a little string. Now, what's a string? A string is just a whole lot of characters like strung together. But I've put this little string, and you'll notice that it's got 3 quotation marks rather than 2 or 1, which is what Julian's been using. And this thing that you're seeing here is what's called a docstring. And what we do is underneath our function, so if we define a function, it's good practice to put a docstring because it tells other programmers what your function does. So if I was to like delete this, if you would like delete a docstring and have a really complicated function, it'd just be a massive headache for other developers because they don't know what your function does. And you might not even know what it does. Let's say you return to your code after like not attending to it like for a few months. So a docstring, it's 10 seconds of effort. It's it will save you lots of time in the process. So it's best practice. So if we were to write a docstring here, what we would probably say is like 3 quotations on each side, and it will be like compute area of a circle. So now we know exactly what it does. And if you remember Julian's help function from before, if we ask for help on this function, it will actually return the docstring. But if that went over your head, all you need to know is that put docstrings under your functions because they tell you what your function does. Okay. So here's a little function that essentially takes in a list of names. Now we know from before that a list is just a whole lot of things inside of square brackets. So if you've got square brackets and then a whole lot of, we'll call these elements in our list. So if we've got a whole lot of elements in our list, this is just a list, elements inside of square brackets. So what we're doing is we're creating a new list and it's empty. So you could imagine this list has nothing in it yet. So we're creating a new list with nothing in it. So as far as we're concerned, new list is just what you're seeing over here. Now, we know with for loops, essentially with for loops, we're kind of bouncing like through each element or iterating through each element. So what we can say is for each n in my list, so what I'm saying is for each name, so in the first iteration, it's going to be John. In the second iteration, it's going to be Jack. In the third iteration, it's going to be Bob. And then in the next loop, it's going to be Mary. So for each of those iterations, starting with John, what we want to do is strip any white space from our word. So what we want to do is essentially with this extract names function, we want to look at our names, and let's say we want to extract all the names that begin with a J. So what I'll do is I'll say, does John begin with a J? Yes, pop it in this list. So John will go in this list. Okay, in the next iteration, it will go to Jack. Does Jack begin with J? Yes, pop it in the list. Does Bob begin with J? No, don't do anything. So we're not going to append it. So it's going to pass by this if statement. Mary, if it starts with the capitalized letter, then put it in the list, but it doesn't begin with J, so we don't put it in the list. So essentially, what we're doing is sometimes in data science, you might have things like countries, for example, that some rows have capital A Australia and some rows have lowercase a Australia. So it's your job as a data scientist doing data wrangling to make sure that they're all just Australia spelt the same way with the same case. So what essentially is happening in this function, I guess to cut some time out and just kind of get on with things, what it's doing is it's going through each name, it's taking away any white space. So it's stripping any white space, which essentially means that John like this and John like this are being interpreted the same way. And then it's converting it to title so that lowercase letters are just converted to uppercase the way a name should be. Then if we're saying, if it begins with an uppercase letter, which you get to choose, so it could be J, then add it to this list. If not, do nothing. So what that really means is once we call this function, and again, you can call this function at multiple stages of your program, you can run this block of code many times over, but without actually typing it multiple times, because that's just inefficient. And there's a concept in programming called dry, or don't repeat yourself. And that's essentially kind of what functions serve the purpose for, being able to use the same code over and over again without repeating yourself, only writing it up once, but using it multiple times in your program. Okay. So in this sense, it takes in a list. So we've told this extract names function that we've defined that it's going to take in a list. And once we call the function, we pass in a list. What's a list? Just elements inside of square brackets. As we sweep through this list, we are going to look for any of the names that begin with N. If it does begin with N, pop it in a new list that just has ones beginning with N. If it doesn't, we don't want it. So if we change this to S, this would take only the ones with S in it, or J, and that will get only the ones with J. And what we've done here is by converting it to title case, so in other words, capitalizing the first letter of the word, we've made it robust to things like lowercase letters. And by stripping white space, we've made it robust to like blank spaces between the word. And this is a pretty crucial thing in data science, because you might have, as I said earlier, you might have Australia, some of the values lowercase, some of the values uppercase, some of them with like little white spaces in between. So I guess it's your job to kind of wrangle the data and ensure that like, there's no anomalies in that sense. Okay. Might actually be easy just to run this code and then explain it later. So, okay. Now, another function. So again, little docstring probably could have been a little bit more detailed, but at least I know what this function now does. It structures an email. Okay. So what we want to do is we want to create a little piece of text that allows you to put any name you want in here, allows you to put any sort of company name, any sort of position name, and then creates an email that when you insert those names, it kind of updates it in multiple places. And I won't go over F strings again, but essentially with F strings, you're doing essentially what's over here. So like whatever gets passed in as hiring manager, that's what gets put in after the word dear and between all of this stuff. If you're wondering what these /n's are, that was just to create a new line. So after the comma, we want to create a new line. So that's where the /n came into play. Double /n, that's just like create like 2 new lines. So new line, so we're over here. So what happens now is that like our function is saying that it takes in all of these, what do we call these? These are parameters. So what it's saying is if I want to change the hiring manager to something else, and I want to change this to like some sort of other company, like Adidas, and then I change this to something else like engineer, yep. And then I change this to something else. What it will do is it will update it at different stages. So that one went there, the Dr. S now goes over there. And so what happens is we, instead of having to kind of keep modifying these lines of code, we can just call this function that we've defined and just change the arguments depending on who we wish to send an email to. So I guess the point of that was not to go through the syntax necessarily, but just to show you that functions can take in no parameters. They can take in 1 parameter, 2, 3, 4. They can take in and as many parameters as you want. Typically, you don't want a function that takes in more than like 5 parameters. But different people will give you different insights on that. But generally, you don't want a function with like lots and lots of parameters just because it's overly complex and you could probably break it up into multiple smaller functions. Yeah. The truly remarkable thing about Python functions is that let me actually just demonstrate it first. You can return multiple values in a function. So if you're coming from other programming languages like C, you can only return like 1 number or like 1 string or 1 thing. Now with Python, you can actually return multiple. So you can have a function with multiple outputs. And let's say I just wanted to return the intro and the conclusion and not the body. I could say, we'll return the intro and we'll return the conclusion. And then if I say, I for intro, C for conclusion is equal to call this function, we can get just the intro. I might have missed I think I missed a bracket there. To make to unpack, I expected to. Okay, what do you have to return as a tuple? Okay, I won't have time to debug that, but let's I will fix that and it'll be in the solutions. Just functions returning multiple outputs. I'll just put a little reminder for myself to actually put that in the solutions just to show that you can have multiple outputs for your function. Okay, so what I might do in this case is finish up with functions. I guess the main point there was just to show you that a function allows you to perform the same piece of code multiple times throughout a program. That's useful because you're not actually repeating the code over and over again. Okay, cool. Now, so that's essentially what functions are. You define it, so def, the name of your function, any parameters, if any, a semicolon to kind of show that, okay, I've now defined my function, a doc string, some code that you want to put inside that function. And if you want to return a value to insert in other areas of your program, you'll return it. Otherwise, you can have functions that just like print stuff, but generally you want functions that return you a value so that you can use it elsewhere. Okay, yeah. So that's probably one of the most important parts of programming, and especially Python programming, is actually not repeating yourself and creating efficient code so that you adhere to the dry principle, don't repeat yourself. Okay, so as I kind of alluded to earlier, everything that we've done up to this point has been in something called base Python. So base Python, and that's sort of what I mean by base Python is just what Python offers out of the box. What Python offers out of the box is just base Python, kind of the bare skeleton that it comes with originally before you start taking other people's code and like putting into your own programs. So I guess that moves us into the world of external libraries. So what's an external library? An external library is code that's been written by someone else that's then where you're now able to take some of that code and put it in your own programs. And what external libraries do is they extend the functionality of Python as a language. Well, they extend the functionality of any programming language because, you know, external libraries have a whole lot of tasks, a whole lot of, you know, input from other developers. And with these external libraries, you can do some fantastic things with your Python programs. One external library that we're talking about will be Pandas. And what's happened was one developer, or actually a few now, developed this external library called Pandas, which gives you an opportunity to analyze large data sets. We can't really do that with just the Python that we've kind of seen up until now. We actually need the help of other libraries and other people's code to like do our own tasks. So in that case, we'll use Pandas, which is a data science library that's used to manipulate data. There are libraries that exist to send automated emails. There are libraries that exist to build complex mathematical models. If you can think of it, there's probably a library that does it. There's libraries that can visualize your data for you. So let's say you have large data sets. If you want to visualize it, there are libraries that do that too. And in fact, Pandas that we're talking about can actually do that. But kind of what we saw before is if we want to use this library, what we can say is we want to import this library into our program. So we'll import Pandas. Now, every time I use Pandas, I'm going to have to type. I'm going to have to tell Python, write down Pandas. And what's going to happen now is that every time I want to use something from Pandas, I'm going to have to type in the whole word, Pandas. So to avoid that, why don't we just nickname it as PD? So instead of typing Pandas every time I want to do something related to Pandas, I can just do PD instead. And that's what this as keyword does here. So if we kind of summarize this, we want to import functionality from this library that you're about to learn, Pandas. And whenever I'm referring to it, I'm not going to actually call it Pandas. I'm just going to call it PD instead for ease of typing. Now, you can just do Pandas, but especially with longer library names, it's nice to alias them because, you know, it just makes sure that like your lines of code like don't go like all the way to here or something, just because you have like a long library name. So it's always good to like alias your libraries, and this you'll pretty much see this everywhere. So we'll import Pandas as PD. Okay, so what you're going to notice is that I'll see if Julian can maybe attach the link. We've got something called a CSV file. Now, if you're not sure what a CSV file is, just think like an Excel spreadsheet or like a table with some values of data in it. So it turns out that with this Pandas library, we're actually able to take CSV files and bring it into our program and like manipulate them in unique ways. So this is the CSV file, and essentially what we're doing with this Pandas library is we're giving the opportunity to actually take this CSV file and bring it into our program. Once we have the file loaded in, we can analyze some of this data. Maybe we want to see, we want to get some insights on the sales, or we want to get some insights on which subcategories, like did chair sales do better than like label sales, or what about different cities? How was sales in Miami different from sales in like Los Angeles or something like that? So the way which you do that is you essentially call the name of the library. So we want to use the Pandas library. So we'll type in PD, and one of the functions that Pandas has to offer is something called read CSV. So what it does is we're saying, okay, Pandas, we want to take the CSV file. What is a CSV? Just comma separated values, just an Excel spreadsheet. Yeah.
We have like 5 minutes, maybe until the event ends. So if you could wrap up, that'd be great. Thanks.
Absolutely, absolutely. No problem, no problem. Okay, so what we want to do is we want to tell Pandas, okay, take in this CSV that we've got from the internet and read it into our program here. So we can pandas.read CSV. And what that will do is it'll take this CSV file and now we can use it in our program. If we want to use it at multiple stages of our program, we can store it in a variable because that's essentially what variables do. They hold data so that you can use it elsewhere. So why don't we just call this data set orders so that we can take our orders data set. So this is like all of our orders and we want to do some further stuff to it. Now, we won't actually have time to go into more of the intricate nuances of pandas, but pandas is a library that you can really like wrangle data sets and get like some tremendous insights out of your data. So we will be offering a pandas workshop probably down the line. If not, we'll have some content on our YouTube channel. But essentially, if you go to our solutions, we have some pretty well documented code that just shows you how to use this external library in your own program and do some like very basic sort of functions. So that is in the solutions notebook. That's something you can just download from our GitHub page and just run each cell individually. And you'll see it's quite well documented. There's comments in the code so that you can kind of understand what each thing is doing. I guess just to sum it up, the reason why you're learning things like lists and dictionaries and basic arithmetic is so that you can take these external libraries that do far more complicated tasks and use your knowledge of these basic programming paradigms to actually create some pretty meaningful programs that can do some tremendous things. So I guess that wraps it up for the code part, and I'll pass it back to Julian, who just kind of wrap up the workshop and just some further steps of action, I guess. So I'll stop sharing and I'll pass that to Julian.
Yep, thanks, Noah. Yeah, definitely. Recommend everyone finish the notebook yourself in Pandas because it's all there's a lot more exercises there. It's correct, Noah, right? There's like a couple other stuff you can do there, so definitely check that out. So that wraps up the event pretty much. Just one last thing, we urge everyone to fill out the feedback form, please. And I guess while we're doing that, if anyone has any questions, that'd be great. Yeah, Noah, could you post the link for the feedback form in the chat, please?
Yeah, sure.
Great, thanks. While we're doing that, yep, thanks, Noah. I'll talk about some upcoming events for DataSoc. So we have our LinkedIn photo shoot and our assessment center coming up. So don't forget to fill in the rego for that. I'll also notice there's a question from Ben. So what UNSW courses are using Python? So if I'm not mistaken, what's the software engineering fundamentals one called? Comp 1531. Yeah, something like that. Exactly. That's one. That's the one more for comp sci engineering students. For the data science degree, I'm not sure where you're studying, Ben, but for data science students, there's actually no Python course, which is why mainly we offer this workshop, is to get data science students caught up with what they need to know for later years when you have to do Comp 9417, which is in Python, and you have to use some pretty advanced stuff like Pandas, scikit-learn for machine learning, NumPy for a linear algebra, matplotlib for plotting, all this advanced stuff. So yeah, that's a good question. Noah, do you have any other courses that use Python? I can't really think of any right now.
I know Comp 9417 uses it. Database, I think through Comp 3311, I think they use it there.
Yeah, definitely.
Yeah, so they use that in conjunction with SQL. So if you're not familiar with SQL, SQL is just a way of interacting with databases. It turns out that we can actually interact with databases not only through SQL, but also through Python libraries that kind of link up with SQL. And I guess that just shows you how powerful Python is as a language, not because of its tasks that it can do on its own, but also how it can work with other programming languages at the same time.
Yeah. Julian's also asked C1 versus matplotlib. I find that C1 is kind of slow. Matplotlib is a lot faster, but C1 looks a lot nicer. It really depends. If I'm not going to be showing anyone my graphs, so for context, C1 and matplotlib are both for graphing or plotting. C1 is a lot nicer. It's like physically the graphs look a lot nicer. But if you kind of want to do some quick and dirty visualizations, I usually just use matplotlib because it's a lot faster. And yeah, I don't really care what my graphs look like, to be honest. Yeah. Hopefully everyone's filled up the feedback form. And with that said, if everyone could turn on their camera, that'd be great. And we could take a quick photo. So I'll stop sharing, and for everyone, if you're willing, turn on your camera, please. Okay. Cool. 3, 2, 1, smile. Thanks, everyone. Cool. Yeah, with that said, if no one has any other questions or anything, you're free to go. Thanks, guys. Hope you really enjoyed it.